Hi everyone, this is Satish, Department of Civil Engineering. So today we are going to see regarding pumps. So pumps are nothing but which converts electrical energy into mechanical energy. So as already you have studied those things in each subject itself. So different types of pumps, efficiency of pumps, okay, pressure head, delivery head, okay, rising main and all. So it is also one of the major part in water supply system. So pumps plays in very much important role. So to generate a pressure, adequate pressure required in a distribution system, or to pump the water from a lower elevation to a higher elevation. Okay, so you can say from source to your distribution system itself. Okay, so pumps plays in very much vital role out here. So now requirements of means why you require a pump in water supply schemes. And again, as I stated earlier itself, when okay, you need to pump the water from a source to a higher elevation. Okay, so when water is not flowing under the action of gravity, so what we do is you need to have that pumps over there. Again, in your treatment plant, so in your treatment plant, if there is not sufficient amount of slope is being provided, or you are not enabled to generate an adequate pressure, for example in your filters, so especially in the rapid and pressure filter itself, so what we do, you need to have their pumps itself. Again, to supply the water from to a service reservoir, so you can see in the Nifani city itself there are many service reservoir at a higher elevation. So your treatment plant, like when you consider Nipani city, that is near Talab itself, it is on a lower elevation, and you require to pump that water to a higher elevation. So for that, the pump is required. Okay, another one. So if you don't have an adequate pressure or pressure head in your distribution system, you need to post it. So the pumps are the best suited for that. Okay, for example, if there is a 3-story building, okay, so there is a not adequate pressure head in your distribution system, only that pressure is being provided in such an extent that the water can reach up to second floor. So what about third floor? So for that reason, what we do here is you tend to provide a pumps. So there are different types of pumps. So one is a rotodynamic pumps, one is a displacement pump. So we'll see one by one. So what is a rotodynamic pump? So it is nothing but it has gotten a rotating element over here. Okay. So or a rotating wheel also you can say it, which rotate in that casing itself. By rotating, what it does, it imparts energy to that water itself. Okay, so that rotating element we call it is an impeller. Again, based on that, what there are based on the impeller, what we have is we have different types of flows. One is a radial flow, one is a mixed flow, one is an axial flow. So what is a radial flow? So radial flow is nothing but when the water is being forced at a right angle direction towards or toward to its axis. So that is nothing but an radial flow. So what is an axial flow? So axial flow is nothing but when it is directed radially to its axis itself. Sorry. Okay, so I stated wrongly over here. So mixed flow. Okay, so mixed flow is nothing but in that flow what happens there is the water is being forced, okay, both as well as axially as well as in radially itself. Okay, so in axial flow what happens there is the water is flows it's been forced, or can say in the direction of axial only. Okay, so based on this concept we have got two types of pumps. One is a centrifugal pump, one is an axial flow pump. So what is a centrifugal pump? So centrifugal pump is nothing but it's a mixed flow. So what is a mixed flow? Both axially as well as radially the water is being forced over there. And an axial pump. So axial pump here is nothing but it flows the water in axial direction only. Okay. Next, priming. So priming is a major factor in centrifugal pump. So what we do is you put water in the casing. So when you put the water in the casing, whatever the air traps is been there, that is being removed. Okay, and it doesn't hinder the operation and efficiency of that. Next one, these are the some of the advantages of centrifugal pump. So it has got less maintenance cost. Comparatively, the initial cost is less. Okay, it is compact, it can be easily installed, the mechanism is cheap. Okay, so skilled labors requirements, if less skilled labor also he can operate and he can repair it. Okay, you can connect it to 10 gas turbine or steam turbine itself. Again, what we can do is, again what happens here is, the flow is very much steady flow. So when is the steady flow, what you can see with we have seen in EH also, steady and unsteady flow. When the flow is steady, okay, there is less wear and tear of that distribution system itself. Again, we can pump that water if it is containing silt and sand. So this type of motor is why it is being commonly used, because it can handle silt and sand. Okay, so there is not much effect on those pumps itself. Even we can use it for sewer pumping also, and this pump is quite durable and safe and high pressure. Next one, some of the disadvantage. So some of the disadvantage here is, okay, there is priming requirement. Okay, one more thing, when you start up a pump, the valve should be always open. There should not be any overloading of that one. Okay, and when you start up the pump, the valve should not be closed for a longer time, because there is a high pressure, there will be breakage in that pump or breakage in the distribution system. So chuck valves are being provided. It's nothing but it's a non-returning valve. There should not be any backflow of water in case of an power failure. Okay, so it is efficiency is little bit quite low over here. Okay, and the section lift is limited to 6 meter. If it is more than that, you need to provide different types of pump. Those are nothing but turbine pump and submersible pump. Okay, so these are special type of centrifugal pump, and their initial cost is very much high. And the discharge, it varies with varying head. So it is one of the major disadvantage. Okay, next one, displacement pump. So displacement pump is nothing but it works under the principle of mechanicals. Okay, so it includes a vacuum chamber over here, a sucking certain volume of water. Okay, and the water in, then what happens there is, it is being displaced with the help of mechanical, and it is being forced out from that chamber itself. Again, there are two types. One is in reciprocating pumps, another one is in rotary pumps. Now there are certain factors. Based on this, you have to select which type of pump you required. Okay, the first one is based on the capacity. Capacity is large or small. Based on that, the importance of water supply scheme. How much that water supply scheme is important to you. Pumping arrangement, 1 stage, 2 stage. Okay, so maintenance cost. Next one, space requirement, number of unit requirement, total lift. So what will be that quantity of you can say how much head you are lifting up. Okay, so total quantity of water need to be pumped over here. Next one, so there are certain formulas. Based on that we tend to calculate the horsepower and all. Okay, so first one is total head. So total head consists of section lift, delivery head, and the losses. So losses may be due to entry and exit. So H is equal to what? HS plus HD plus HL. So this one you can see in your EH book also. Okay, so now work done of that pump. So it will be in terms of lifting of water. Okay, that will be in terms of quantity, that is Q. Okay, it will be in terms of cubics with respect to certain head H. So that is nothing but it is been given as gamma W Q H in terms of kilonewton per meter or it can be represented in terms of joules per second or watts. So to calculate an horsepower to calculate an water horsepower of the pump, this is that equation. So that is nothing but gamma W Q H divided by 0.735. So it is nothing but 1 HP is equal to 735 watts equals to 0.735 kilowatts. Sorry, this is watts, this is kilowatts. So now BHP, okay, that is nothing but brake horsepower. So that is equal to what? That is equal to WHP divided by nu, that is efficiency. So here WHP is being given by this equation. So now this equation becomes, okay, rho WQH divided by nu into 0.75. So these equations will be very much helpful or handy in calculating the problem itself. Now here this is one of the major aspect or major point, so that is called as an economical diameter. Okay, so this we will continue in the next video itself. So thank you very much. Stay tuned so that we can continue with respect to what do you mean by an economical diameter. Thank you.